Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of a rational function. Rational functions in general have a fractional appearance in which there's something over something else and we have some sort of denominator, and there's usually a variable in that denominator. Okay, and we have to make sure that g of x can't equal 0, right? That's part of the domain rules we've already gone over. And in graphing these rational functions, which is the main thing we'll deal with, you have to do a few basic things. So the first thing is you got to find your intercepts, your x-intercept and your y-intercept. You always set the opposite variable equal to 0 and you solve. Okay, so if you're trying to find the point that crosses the x-axis, the x-intercept, you set y equal to 0 and you solve, and the answer will have this typical form right there of number comma 0. Whereas if you're looking for the y-intercept, you set x equal to 0 and the number, or the point, looks like this, 0 comma number. Alright? And after you find your intercepts, you should go about finding vertical asymptotes. Vertical asymptotes are going to be your vertical barriers that the function cannot cross no matter what. Okay. Now you'll find for horizontal that's not always the case, but for vertical you cannot cross. Okay. And the way we find them is we set that denominator g of x equal to 0 and we solve. Now be careful, sometimes some of the factors of h of x will cancel out with the factors of g of x. So even though it's outside the domain, it's not a vertical asymptote. It's a removable discontinuity. It has this open dot look here that I just highlighted. Okay, so just be careful, factor out the numerator and the denominator, make sure stuff doesn't cancel. If it does, then it's not an asymptote, it's a little open dot like that. Okay, how do we find the horizontal asymptotes? Well, the horizontal asymptotes, we got to do some comparisons of the numerator and the denominator largest exponent. So what we got to keep in mind here, you can cross a horizontal asymptote in the finite regions. What do I mean by that? I can cross the x-axis even though there is an intercept at y, or an asymptote at y equals 0. And I'll show you an example of that in my example videos. So again, you cannot pass at the extreme values, okay, x values. The only time you can cross a horizontal asymptote is if we're in the finite regions. But as x gets really, really large or really, really small, then the asymptote comes into play. How do we find that thing? Well, we look at the exponents of your function. If this is your f of x, and this is the largest term of the numerator, and this is the largest term of the denominator, whenever the denominator exponent is larger than the numerator, we got y equals 0. But if they're equal exponents, then we divide their coefficients. And if the numerator exponent is larger by 1, we have what's called a slant asymptote, and you do long division. Whatever's not part of your remainder is your slant asymptote. Okay? And by 2 it becomes parabolic asymptotes, stuff like that. All right? I don't think you'll get too much into those, but just in case you do, I want you to be aware of that scenario. Okay. I will be doing these two examples here on my first example video for rational functions. Make sure you check them out. But find your intercepts, find your asymptotes, set the bottom equal to 0, compare the exponents. And then what you're going to do after that is you're just going to put a test point, a sign analysis on either side of your asymptotes and your intercepts. Okay, and if we're above the axis, we get a positive value, then that's where you draw your function. These are rough sketches, these aren't precise graphs. Okay, so check out the example videos and it will further clarify any confusion you might have. Thank you and have a nice day.